So these are the topics we have in the first module, and I told something about IoT on the other day. So Internet of Things is the network of physical objects embedded with electronics, software, sensors and network connectivity, which enables these objects to collect and exchange data. Okay, so we are converting the raw data into knowledge form. Okay, so for that we discussed a few things, and this is a simple layout of IoT diagram, and this is another example for a IoT example like everyday timing, days, energy consumption, building management, security and surveillance, embedded mobile, agriculture, wireless sensor network, telemedicine, healthcare, everything. Okay, everything is connected for smarter. Uh, the existing system may become smarter with the help of IoT. So that's the concept. So this two diagram, I got it from Google. And what are the characteristics we discussed on the other day? The first character is dynamic.
Ma'am, actually, are you changing the slides? Because it's stuck on one only for us.
Slides are not visible.
Only one slide is visible. Are you changing the slides?
Yeah,
Yeah,
ma'am.
now it's visible.
Characteristics is visible, right? Characteristics. Yeah, and I'm
Yeah,
discussing
ma'am.
about characteristics. Yeah. So first characteristic is dynamic global network and self-adapting. So the existing systems, when it is uh, changing to the new environment, or the capability to dynamically adapt the changing context based on their operating conditions and user context is said to be the first characteristics. Dynamic global network and self-adapting. And the next thing is self-configuring. So if you're providing a connection between physical as well as logical, if you're providing that connection, automatically everything should be get ready. Okay, so the IoT devices have the ability to configure themselves, set up the networking, and fetch latest software upgrades with minimal user intervention. So that is the uh, concept behind self-configuring. And I told you about interoperable communication protocol. So we have different types of protocol. Each and every protocol may have their own characteristics or features. Everything is adaptive for IoT devices. And the next comes unique identity. As you people are working with address, right, IP address. So like that, each IoT device may have some unique identity, like your Arduino or Raspberry, whatever. So that would be capable of providing the normal configuration as well as connection between the various things which are connected with. And the final thing is integrated into the information network. So this allows to communicate and exchange data with other devices also to perform certain analysis. Why we are connecting, why we are communicating everything, what is the purpose, what is the raw input we are going to give, and what is the output we are uh, retrieving. Okay, so everything can be integrated. And these are the characteristics of IoT. And I gave you a small example how the raw data can be converted into knowledge. So initially we are calling it as a raw data and unprocessed data obtained from different systems. And then it can be converted into information by filtering, processing, categorizing, condensing, and contextualizing data. So if you're going for some specific things, these things would be very much useful, and then those informations can be converted into knowledge. What we are calling as knowledge, the knowledge is info from information by organizing and structuring everything, and is put into action to achieve specific objectives, specific goals or specific objective. We are calling it as a knowledge. For that I gave you one more diagram also on the day. uh, so these are the things what we discussed in last class. Okay, so today the next topic, challenges. What are the challenges and what are the issues in IoT? What are the challenges and what are the issues in IoT? So the first thing is scalability. What do you mean by scalability? Scalability is the ability of a device to adapt to the changes in the environment and meet the changing needs in the future. Okay, so for example, I told you an example on the last class. Initially, we have 100 systems, and I wish to add few more to the existing environment. So, just we are adding like some more 100 machines to the existing system, but it is not going to affect the performance of the whole. Okay, it is not going to affect the performance. It means that the existing environment is capable of adapting the changes occur in the future. Okay, so that is the concept. So scalability, how will you define scalability? That is the main challenge in the IoT. It is the ability of the device to adapt to the changes in the environment and meet the changing needs in the future. Okay, so this is one of the essential feature of any system which has the capability to handle the growing amount of work. Okay, so this is very much required for IoT. And here, yeah, I can say one more example. Can scale for scalability. Initially, you may have the operating system as a small scale system. It can be enhanced to larger. It can be enhanced to large scale system. For example, you are developing a simple software or programming code as an individual, and it can be made as a, or it can be enhanced as a project work also, or that could be enhanced again as a again it could be used for some business purpose or health purpose, something like that. Okay, so the small systems can be converted into larger system with the help of this scalability feature. Okay, so the examples of operating systems are said to be the examples. Initially we have Windows 95, Windows 2000, so many things, right? So many versions are available. So that is the thing behind scalability. So you should be very clear with the term. It is the ability of a device to adapt to the changes in the environment and meet the changing needs in the future, right? Fine. The second thing is technological standardization. Technological standardization. So here, the data, what I told you about data, information and knowledge, right? So simply if you're collecting some data for your project work or whatever may be your analysis, you're collecting some raw data. So that should be, that cannot be input as such in the computer system, in the IoT system. So it has to be managed, it has to be processed, it has to be transferred and stored securely. Okay, so the technological standardization is the second challenge. What it is saying, or what it implies exactly, it is a key to achieving universally accepted specifications and protocols for true interoperability between devices and application. So, I think you may heard about the word standard, standard, standard. What is that? It checks the quality. It checks the quality. Okay. You're going to analyze a few papers for your IoT project. Okay. So there you have to go for some standards. For example, IEEE standards. Okay. What is that? Compare with other journals and conferences. This will give you a good perspective view of the particular work. Okay. Something like that. So the data needs to be managed, processed and transferred with the help of the standardization. It can be checked, the quality. The quality can be checked here. So how will you define it? Standardization is a key to achieve universally accepted specifications and protocols for providing the connection. And if you're moving for standardized one, it would be a cost effective and it ensures interoperability. Okay, interoperability in the sense, I tell you about interoperability as the next factor. So it's a cost effective one and we are using standards. Okay, that is one. And what do you mean by interoperability? That is the third challenge. So what is that? I told you IoT is the connection of various devices. Okay, we saw these examples. IoT is the connection of various devices and various fields we are connected with. You people are working day-to-day life. In your day-to-day life, you are working with all these devices without the intervention of IoT now. Okay, but you can see interoperability is the ability of two or more devices, systems, platforms or networks to work in connection. Okay, so it should not affect the performance of one. If I am adding a few more devices to the existing system, it is not going to affect the performance, and all the connection like physical, logical, everything should be performing properly. Okay, functioning properly. That is the concept. And the next thing is, yeah, discovery. Discovery in the sense your findings. Okay, findings. So discovery is a mechanism that will enable application to access the IoT data without the need to know the actual source of data, sensor description or location. Okay, so something you are installing as new. Okay, so it will enable the application to access the IoT data without the need for some sensors, descriptions or locations. Okay, it will automatically do everything. For example, the librarians use discovery to describe the search tools. Okay, so you're moving to your VIT library. There we could be capable of searching for the books. So as a student or as a faculty, just we can type the name of the book or author, something like that. We could be able to retrieve at least in which rack it is available. Okay, so something like that. So discovery is a mechanism which allows the application to access the particular data without the actual source. Okay, without it is not required to know the actual. Okay, so I know if suppose I need operating system book or I need IoT book, where it actually present, I have to go and I can search it from that system, and I should go there and I should pick up from there. Okay, so extra informations are not required. Okay, extra in the sense actual without the need to know the actual source of data, sensor description or location. It is not required for me. Okay, fine. Then the second is yeah, sorry, second is not, fourth. Yeah, we discussed fourth. Fifth one, software complexity. As you know, you people are working Android phones, mobile phones, and we are making software updates. Then and there, we could be able to do software updates. So some complexity maybe arises, like in the security risk, something like that. So what is the thing behind software complexity? Simplifying the implementation of secure device designs and configurations. Okay, it also means that simplifying the process for maintaining security of detection devices in the production deployment. Okay, so it should be simple. The design should be very simple, and how your data is secure, how your data is secure. So that is also the two thing what we have to go while we are talking about software complexity. Okay, some issues may arise due to softwares, but the complexity increases the security risk around the IoT devices, of course, is to simplify that. So if I'm using IoT devices for the particular software complexity, it should maintain the particular thing. It should be in a simple manner. Okay, the design should be in a simple way. And the next is data volumes and interpretation. Suppose for your project, few maybe work with the garbage collection system. Okay, what is that garbage collection system? You are going to collect different type of garbages. Okay, wastage, biogrades, something like that. Okay, so garbage collection, it indicates with the help of the devices if that particular basket is full. Okay, so it may be biodegradable waste, something like that. So if it is full, based on the volume, it will indicate if we are fixing the IoT devices, it will sense that bag is full, it has to be removed. Okay, something like that. So the data volumes indicates we have to analyze about the amount of data. The data is vast, right? You know, big data, a huge amount of data is there, and we have so many complex issues are there, and interoperability is said to be a main thing. Okay, so we are going to connect n number of devices. Each and every device may have their own characteristics and own functionality. So everything should be adapt to that particular change. Okay, initially I can take my input system, and in next step I have to go for executing my task, like processing your system. The next comes, I should retrieve the output what I have done in the processing stage, right? So everything should be interoperable. So input, execution, output should be interoperable to obtain an output. Similarly, if you're talking about data volumes and interpretation, huge amount of data, complexity and interoperability should be considered. Okay, and the next comes, I think, power supply. Yeah, power supply. So as you know, we are connecting devices. We are connecting different devices. So power supply is said to be a major factor And IoT will be the ubiquitous, requiring many small AC and DC supplies to power the sensor network. Okay, so each and everything may need different types of connections, right? So the cost effective one, it should, your power supply should be cost effective, compact, low power supplies. Low power supply is suitable for few IoT installation, but it won't work for everything. Okay, we can't make sure that. And we can use also thin film printed batteries, energy harvesting modules, small flexible photovoltaic panels, and thermoelectric sources, everything. Okay, so each may have a cost as its own, right? So we can't say it's something. Okay, so power supply is said to be a major factor which is very much required for IoT task. The next comes communication. Yeah, communication in the sense, there are different types of communications available: wired communication, wireless communication, radio frequency communication, so many things. We have one chapter, one module for discussing about the communication alone. I'll tell you shortly now what is that. So communication, the IoT short range, if you're talking about short range, so I have my mobile and or a smartphone, which could be connected with a small IoT device, and there should not be any problem with both the devices, my smartphone or smart mobile, or otherwise the IoT. Okay, so the IoT short range technology is to support mobile use cases where a smartphone or other mobile devices can be used as a temporary gateway. Okay, suppose by the end of the semester you are going to implement your project as demo to me. Okay, on such case you may have a device, IoT device, and you are going to show the output. There are different ways to show your output. So if you are choosing a mobile app application to show your output, that is also acceptable. Okay, so how I can call it as a short range. Okay, because we are not going to make use of cloud servers and all, it is said to be a long range one. So which comes in which category, everything we are going to discuss in further modules. So just what is short range technology, what is long range technology. I think medium is also available. Okay, fine. And for example, for this communication, one example is Bluetooth, another one is Zigbee protocol. So many things are there. I have given only two. You know what is the thing behind Bluetooth? If you want to share some photos from my PC to mobile, okay. So what I have to do, it may be a old photos. So I can turn on my device both in my PC as well as in my phone, mobile phone, and I have to share it. Okay. So once the connection, if it is pair, we could be capable of transferring the data. Okay. So that is said to be short range. It could be capable of transferring the data within certain ranges, frequency range. So that's it. And yeah, Bluetooth, the study about Bluetooth, Zigbee, everything will be discussed in further units. And radio frequency is another technology which enables the devices to communicate with one another without being physically connected also. I think you are hearing, some of you maybe some of you may have the habit of listening songs with right, with the FM. Everything is possible. This is also said to be a short range. And the next comes fault tolerance. Wireless communication is also there, and fault tolerance. So what is wireless communication? It is an essential part of IoT infrastructure, and it acts as a bridge for providing dual direction communication for data collection and control message delivery. So it could be, this wireless communication can be applied to various things like IoT applications like mission critical industries, power grid, oil field, and in case in our routine life like a smart city also. Okay, so what is wireless and what is wired. So that is also there. Wireless, everything we'll discuss in protocol or communication media. Okay, and the next comes the fault tolerance. Fault tolerance is said to be it's a simple one. It's a simply this is a common factor also, the fault tolerance. Here what they are saying in IoT, the fault tolerance in IoT emphasizes that it is a system's ability to continue operating uninterrupted despite the failure of one or more of its components. Okay, so I told you we have a connection of different types of devices. Okay, if one devices may got failure, uh, the remaining things should have the capability to continue its operation. Okay, so this is true whether it is a computer system, a cloud cluster or network or whatever, okay, where we are providing all those connections. So wherever it is, this fault tolerance plays a major role. Okay, so this should be quantified with help of some case. Like I can say plus or minus this much value, 0.2 is said to be the fault tolerance value. What it indicates, it could be tolerable with that value, not more than that. If we are receiving something more than that, we should say it is a um, mistake, or we have to do it, redo it, something like that. Okay, so that is said to be a fault tolerance. So it simply means a system's ability to continue operating uninterrupted despite the failure of one or more of its components. Okay, this could be applicable for all the computer systems, whether it is a LAN, MAN, WAN configurations, or in a cloud environment or network, whatever, right? So these are the issues and challenges there. So based on that, we could call it as a challenge or issues in IoT. Okay. So this I got it from different resources and I have highlighted. This is not exactly present in your books and all. So I have brought here 10 challenges and issues are there. You should know what are all those things, and explanation is required for this task. Okay. Yes, ma'am. The next thing is examples of IoT. Examples of IoT. Um, I can say connected appliances. You have a set of appliances and all the connected appliances are said to be an example. And smart home security system, autonomous farming equipment, wearable health monitors, smart factory equipment, wireless inventory trackers, ultra high speed wireless internet, biometric cyber security scanners, shipping containers and logistics tracking. So these are said to be the various example. This also I got it from one of the resources. If you're taking something like that, no, 1 minute, I'll show you what is actually happening with the examples of IoT. One minute, why it's taking some time. See, this screen is visible, ma? Google screen. Yeah?
No,
No,
ma'am.
ma'am.
No.
No. The PPT is visible.
Yeah, wait. See, this is a small example. You can see I can't explain all the projects, so I'll explain two from here. So you can see weather reporting system using IoT. Yes, ma, weather reporting system using IoT. So what you have to do, a weather reporting system is simple, right? We should know what is the humidity, temperature range, or whether the possibility of rain, something like that. Okay, so if you're providing connection in such a way that with the board, right, with the board what we need with a microcontroller chip, and it could be capable of giving a reading of the particular thing. Okay, so a weather reporting system is simple in which we use sensors to measure the temperature, humidity and rain. So they will display the measures in real time. They will display the measures in real time. So you can remotely send this information anywhere also. Okay, this is one of the simple tasks what we are doing with weather reporting system. So how you are going to make use of this, that is also there. You can show the demo with some implementation like this. Okay, so what are the communication media we are going to use, what are the technology we are going to use, everything is there. Okay, and if you're talking about, I told you about liquid level monitoring system. See, by monitoring the liquid level of the system, you may have applications like alerting when a liquid tank is full. Okay, so it will send a notification to your mobile, water tank is 95% full. Please turn off the motor in few minutes. Okay, so this is a small thing because we have some sensor device here to sense the level of the liquid, So we can build a smart system that can fill a tank with liquid without overflowing. Okay, this is what's said to be another task, liquid level monitoring system. Then one more thing is soil moisture detection. Okay, so suppose at our homes we forgot to pour water to our plants. So if it can automate the process. Okay, can automate the process using watering process. So for that, how will you build an environment? So soil moisture sensors can be used to detect the moisture in the soil, and you can then water the plants according to the soil moisture, whether that much particular moisture content is enough. Okay, the range is there, right? So if it is okay, or if it is very dry, if it is wet, whatever will be identified. For that, you have to do one more task. It is said to be soil moisture. And fire detection system is another example. So you can see smoke detector, narrowband IoT platform, and fire department. So it spreads at a quick rate. The fires will spread at a quick rate, as you know, and it is necessary to take action as soon as possible. Okay, so you can build a fire detection system that will alert the owner of the building. So you can do something like that. This is another example, another ideas. So something like that. If you're searching in Google, you have different ideas, but what you are using as a tool, how we are going to provide that connection between the IoT devices and various things, what we are going to use, everything is there. Okay, so air pollution controlling monitoring system and controlling system. Okay, so they have given few things like that. And Raspberry Pi, this is one of the tool which is meant for implementation, Raspberry Pi and Arduino. So these are the examples of IoT tasks. Raspberry Pi can be used to make a smart mirror, right? I think many of you have their habit at their homes, like a smart TV and all. So which could be capable of displaying all these things. So this mirror not only shows your face, but also can display the real-time weather nodes, etc. I think you may uh, work with all these things, I think already. It uses a large display, so you can use any old LCD or LED monitor TV and convert it into a smart mirror. Okay, so this can also be implemented. And server room temperature monitoring system, right? Your air condition system, you are using air condition system. So according to the temperature outside the range or within our home, so what is that, everything can be check it out. And a self-balancing robot, I told you robot is somewhat expensive, so it's up to you to choose it. And automatic drawing machine, it's one of the new tasks. I'm not aware of this. Wait. Yeah, automatic drawing machine in which through the program we control the arms of the machine containing a pen. Okay, so no one worked with that so far, I think. Okay, and smart parking system using IoT is a very good example. Many of them have this idea maybe. So we have a base station and will detect whether what is the uh, in which within the range that device is there. So it's hard to find a parking space. A small parking system is a solution to the problem. To build this, we need to fit sensors at each parking space, and they'll communicate to the communication station that will display which parking space is occupied and which one is free. Okay, the slots are empty or free, something like that. And health monitoring systems, surveillance camera, everywhere you have that in malls, right? Very big buildings, you may have that as surveillance camera. So it is cheaper only economically, but what is actually doing is there. So they can be helpful for monitoring elder people or kids at home, something like that. And IoT project health monitoring system, I told you different. Like for humans, we have blood pressure, temperature level, ECG level, everything. So that could be identified with the help of this health monitoring system. And a few things is also there. Okay, so what I have given as a topic for a few things I have gathered from different resources only. So you can make use of that. So this everything is said to be example. Okay, examples of IoT. So in all the implementations, while we are analyzing about your project, each and every in each and every step you should know what is the topic. First, for the project review 1, you should be very much confident about your topic. You choose your topic. I told you that topic should be okay for all your team members. Okay, and for I need abstract. The abstract should not be a copied content, right? Abstract should not be a copied content. You should write it by yourself in English. Okay, about 15 to 20 lines. Okay, so what is your idea exactly with a title? For example, IoT in smart city. If you want to implement some task in the city, IoT in smart city, what is your idea? Something like that is required. Okay, and what is the software, hardware, everything. So on this Saturday, Sunday, I'll make a project instruction and that will be available in your VTalk. Monday, I'll tell you. Okay, so I'll show you and I'll explain that one more time. Already project review dates are available in your VTalk. How many of you have checked it, ma? How many of you have checked it? Project review dates.
Actually, ma'am,
Yeah, so project review 1, 2, 3. So I fix 1 week for each and every reviews. So based on that time you don't have class, you have review. You should review. You should present me. Okay, as a team members. I'll make you people as a presenter and you have to tell me. And I told you, have you formed the teams first? So within this,